Hello future engineers, welcome to my YouTube channel. Here is another video about the solution to 2D plane trusses or two plane trusses. This is part 2. So this is the problem. Identify zero force members and then find the force in the lettered bars A, B, and C. You may label the zero force members with small letters, but in this case, I will directly specify the zero force members. So by taking a look at this truss, at this joint, this member is zero force member. So take note of case 2 where we have two collinear members. This is the unique member. There are three forces, two are collinear, so therefore this member carries no force. Also at this support, which is a roller support, the two forces are again collinear, so this member is a zero force member if you sum up forces along horizontal. Then for finding A, we have to consider this section here, cutting section. Then we isolate this as free body. This is not the free body diagram. So that is A, and these other two cut members will meet at this point or joint, which I call joint 1. So summation of moments about joint 1 equals 0. So clockwise moment equals counterclockwise moment. So 8 times 6 equals 60 times 12. So A therefore is 120 kilonewtons. Then to solve for B, C, members B and C, the plan is to cut or pass this cutting section and isolate the right portion. So we need to solve for the reaction at this roller support. Vertical reaction R, we sum up moments about the left support equals 0, counterclockwise positive, so R times 6 plus 6, so 12, plus 60 times 6, then equals 10 times 24. So R is negative 10. Having found R is negative 10, we then pass that section, and this is now the free body diagram. There are 1, 2, 3, 4, 5 members cut, but they are reduced to just 4 because this member carries no force. To solve for B, we sum up moments about this joint, which I call 2. Actually, that is also joint 1. I just mark it with 2. So the slope of B is, because that is 6 and this is 6, so 1 horizontal, 1 vertical, square root of 2 hypotenuse. The component of B that has moment about this joint 2 here is the horizontal component, so taking counterclockwise moment positive, so the horizontal component of B, B times 1 over square root of 2 times 6 plus 120 times 6, then equals 10 times 12. Solving for B, it is negative 141.4 kilonewtons. Then finally, summation forces vertical equals 0. So we have upward R, which is negative 10, then minus this load 10, minus the vertical component of B, which is minus quantity negative 141.4 times 1 over square root of 2, then minus the vertical component of C, which is C times 1 over square root of 2 equals 0. So solving for C, C is equal to 113.1 kilonewtons. So for this problem, You may solve this in your own way, but I just present the way I solve it. And if you want to follow it, then just follow the technique. But there are many ways to solve this problem. So first, we will solve this, the force of member C, and introduce this section so that there will be four members cut, C, D, and these two members here. These three members meet at their lines of action meet at 1. This is the free body diagram of the section members considering the upper part. So remember that the span or distance between supports is 32, and this is the center, therefore half of 32, 16 and 16. Summation of moments about this joint here, 1 equals 0 and counterclockwise positive. So we have C times 32 plus 500 times 16 equals 0. Solving for C is negative 250 kilonewtons. We then proceed to joint 2, and this is the free body diagram. This is C, negative 250. I introduce this as member F, and the horizontal member at 2 is D. Of course, the slope of this member F is 16 horizontal to 6 vertical, which can be reduced to 8 horizontal, 3 vertical, and so does hypotenuse is square root of 8 square plus 3 square, square root of 73. Summation versus y equals 0. Vertical component of F is F times 3 over square root of 73 equals downward force negative 250. Solving for F is negative 712 kilonewtons. Then we sum up forces. Horizontal equals 0. Then we have negative 712 times 8 over square root of 73 plus D equals 0. Solving for D is 2000 over 3 or 666.7 kilonewtons. Then we draw the FBD of this joint. So the horizontal component of reaction at the support is 0 because there is no inclined load. Then this is the force C, member C, negative 250. This is the horizontal member, that joint. Then this is the member E with slope 8 horizontal, 6 vertical. That 8, 6 can be reduced to 4 horizontal, 3 vertical. So the hypotenuse is 5. Summation forces y equals 0. Vertical component of E is E times 3 over 5 plus 250 plus negative 250 equals 0. Since this is 0, E is 0. If E is 0, if we need to solve this summation versus x, then this is also 0. But not needed. I proceed directly to this joint 3 here. So take note that we already solved D, and this is member A, this is member B. So since this is E, which is 0, this joint reduces to case 2, where two members are collinear and we have a unique member, unique force. Therefore, this unique force is 0. Remember, by case 2. Or, to prove that this is 0, sum up forces vertical equals 0. Vertical component of B plus nothing equals 0, so B is 0. Finally, you can remove E and B 0, then we have two forces that are collinear. So since they are collinear and they are in equilibrium, then they are equal. That is A equals D equals 2000 over 3 or 666.7 kilonewtons. So that's it for this video.